This is Algebra 2, Unit 10, Lesson 11 on the remainder theorem. Now, in the last lesson, we saw how two polynomials, when divided, result in another polynomial and a remainder. The remainder has a remarkable property in certain types of division, so we're going to explore this relationship in the first exercise. Okay, so what we are going to do is we are going to divide these polynomials and then look at what happens with the remainder. Okay, so let's use long division. Alright, so we want to set this up, x minus 2 on the outside as your divisor, and then x squared minus 8x plus 18 on the inside. Alright, so remember you want to look at the x and the x squared. X times what is x squared is x. Remember you have to multiply both of these terms, this and this. So this is going to be x squared minus 2x. Okay, now remember you have to subtract. Remember I like to put the signs here so I know I changed them. That becomes plus, so these are going to cancel out, and then negative 8 plus 2 is negative 6x plus 18. Okay, and then we repeat the process. X times what is negative 6x? Well, it would be negative 6. Multiply both of these, you get negative 6x. Negative times a negative is a positive 12, and then I want to subtract, so I'm going to change my signs. That'd be minus. So 18 minus 12 is going to be 6. Okay, so my answer for this, when I divide it, is x minus 6 plus 6 over x minus 2. Okay, now it says simplify division and then evaluate p of a. All right, now a is the value right here. So a is without the sign. So a is going to be the value 2. So if we take p of 2 and plug it into this equation, 2 squared minus 8 times 2 plus 18. If I grab my calculator, I can probably use my head, but I'll do it quickly here. 2 squared minus 8 times 2 plus 18. And I get 6. Okay, so that equals 6. Okay, now notice something here. My remainder, or excuse me, when I plugged in p of 2, which was this value right here, I got 6. Where else do you see 6 in this problem? Oh, look at that. The remainder is 6. Let's see if that happens again. Let's try the next one. All right, using long division. X squared minus 2x minus 25 divided by x minus 7. So I set this up as my divisor is x minus 7. And then I have x squared minus 2x minus 25. All right, so x goes into x squared x times. Multiply both of these. X times x is x squared. X times negative 7 is negative 7x. Okay, you want to subtract, so change your signs. I'm putting them in a circle so I know that I did them. So x squared minus x squared is 0. Negative 2x plus 7x is going to be 5x minus 25. Okay, so x times 5, what gives me 5x, would be plus 5. Multiply both of these terms. 5 times x is 5x. 5 times negative 7 is negative 35. Change your signs. And you get negative 25 plus 35 is 10. So my remainder is 10. So my answer is x plus 5 plus your remainder of 10 over x minus 7. Okay, now let's try plugging in the a value. What is the a value of this again? The a value right here is going to be 7. Okay, so when I plug in 7, I have 7 squared minus 2 times 7 minus 25. All right, so if I go to my calculator, 7 squared minus 2 times 7 minus 25. What do I get? I get 10. Ha! That's going to equal 10. All right, so when I take this and I plug in the a value of 7, I got 10. What was my remainder? My remainder was 10. Huh, it's working again. Well, let's try this one out. 2x squared plus 11x plus 11 divided by x plus 3. All right, 2x squared plus 11x plus 11. Okay, let's try the same process. X times what gives me 2x squared? would be 2x. Multiply both of these, 2x squared plus 6x. Okay, then I want to subtract, so I'm going to change my signs. 11 minus 6 is 5x plus 11. Okay, now I want to multiply x times what gives me 5x? Would be 5. 5 times x is 5x. 5 times 3 is 15. All right, change your signs and add. So this becomes subtract, this becomes subtract. 11 minus 15 is negative 4. Okay, now what do you predict if I plug it? Why is this negative 3? Well, if this is x plus 3, remember it's in the form x minus a. This is actually x minus negative 3. So that's why this is negative 3 and not positive 3. Okay, so when I plug in negative 3 here, what do you think I'm going to get when I plug this in? I bet I get negative 4. Let's see if I do. All right, so if I do 2 times negative 3 squared plus 11 times negative 3 plus 11. Let me grab my calculator. 2 times negative 3 squared plus 11 times negative 3 and then plus 11. Okay, is negative 4. Look at that, it worked. Okay, so when I plug in this value, negative 3, I ended up with a remainder of negative 4. So my answer on here, when I divided this, was 2x plus 5, forgot to put it down here, plus, or minus actually, 4 over x plus 3. So my remainder here was negative 4. All right, we're leading into the remainder theorem when we're doing this. Okay, now 3x squared plus 7x minus 20 divided by x plus 4. Let's divide it out. 3x squared plus 7x minus 20. Okay, x times what gives me 3x squared? Would be 3x. 3x times x is 3x squared. 3x times 4 is 12x. Okay, now we're going to subtract, so change your signs. This becomes subtract, this becomes subtract. 7 minus 12 is negative 5x minus 20. Okay, x times what gives me negative 5x? Would be negative 5. Negative 5 times x is negative 5x. Negative 5 times 4 is negative 20. And change my signs and add. And I end up with 0. Okay, so when I divide 3x squared plus 7x minus 20 by x plus 4, I end up with 3x minus 5. All right, so is there a remainder on this? No. That means that x plus 4 is a factor. All right, so let's see what happens when we plug in negative 4. What should we get? Well, we probably should get 0. Let's see if we do. 3 times negative 4 squared plus 7 times negative 4 minus 20. 3 times negative 4 squared plus 7 times negative 4 minus 20 is equal to 0. So that equals 0. So that tells me what about this? Well, that tells me when this is 0 is when the remainder is 0, x plus 4 is a factor of 3x squared plus 7x minus 20 because it goes in evenly. So if we were to factor this, 3x squared plus 7x minus 20, it factors as 3x minus 5 times x plus 4 times x plus 4. The x plus 4s are going to cancel, leaving 3x minus 5. All right, if you did it by long division or whatever. So when you're doing a long division, when you have a remainder of 0, that means that this is factorable. So you could factor this and cancel stuff as well. So when the remainder is equal to 0, whatever you're dividing by is a factor of the polynomial. So we have come up with what's called the remainder theorem. When the polynomial p of x is divided by the linear factor x minus a, then the remainder will always be p of a. Basically, when you divide by x minus a linear factor, whatever this is, or the opposite sign, will always be, and you plug it in the formula, will always be the remainder. So if we want to know if a polynomial has a remainder, if it goes in evenly, all we have to do is put in the divisor number here and see if it equals 0. If it equals 0, that has no remainder, it's a factor. If it has a remainder, you know immediately what the remainder is, and it's not a factor. Okay, so let's see what that looks like. If the ratio x squared minus 11x plus 22 divided by x minus 9 was placed in this form, so quotient with the remainder, r is the remainder, where q of x is a linear function, okay, which the following is the value of the remainder. Remember, r is the remainder. So instead of having to do the long division, or any other kind of division that we could do, all you have to do is plug in whatever the a value is in this. Now, what is the a value if it's x minus 9? Well, that means that a is going to equal 9, because it's just this value. It's the opposite sign of whatever's there. All right, so then take that and plug that in to this equation, into the the polynomial you're dividing. So that would be 9 squared minus 11 times 9 plus 22. If I grab my calculator, 9 squared minus 11 times 9 plus 22. And I end up with 4. Okay, so that should equal 4 is my remainder. Okay, so the value of the remainder should be 4. Now, let's check and make sure we're right. If I did the long division on this, x squared minus 11x plus 22, x times x is x squared, so that gives me x squared minus 9x. Change your signs. You get negative 2x plus 22. X times negative 2 is negative 22, or negative 2x, excuse me. Negative 2 times x is negative 2x. Negative 2 times negative 9 is positive 18. Subtract, and you get 22 minus 18 is 4. Look at that. So a shortcut way of knowing what your remainder is taking whatever you're dividing by in the form x minus a, take the a value, plug it into the equation, and see what the number is. If it has a number other than 0, then that would be the remainder. If it is 0, it will have no remainder, and that means it is a factor of the polynomial. In the past, the remainder theorem was used primarily to aid in evaluating polynomials. These days, it is the primary justification for telling if a linear expression is a factor of a polynomial. Okay, so by definition, x minus a is a factor of p of x if p of x divided by x minus a is equal to q of x, where q of x is another polynomial. What must be true of the remainder p of a for x minus a to be a factor of p of x? Okay, now, if this is a factor of p of x, then the remainder, if I was writing it p of x divided by x minus a, is equal to q of x. Now, in general forms, this would be the remainder over x minus a. Well, if for p of a to be a factor, we would have no remainder. To be a factor, there would be no remainder, so what would r have to be? So if there was if to be a factor, there is no remainder. So r would have to equal 0. So if you use the remainder theorem and your remainder is 0, that means whatever you're dividing by is a factor. So without even having to divide, you can figure out using the linear factor whether or not this goes into this or not, what its remainder is. Okay, so let's look at that down here. Determine if each of the following are factors of a list of polynomials by evaluating the polynomials. Is x minus 3 a factor of p of x equals x squared minus 11x plus 24? All right, so I need to know what my a value is. What is my a value if this is x minus a? All right, a would have to be 3. So if I take p of 3 and plug it in, I get 3 squared minus 11 times 3 plus 24. So when you plug in 3, it does equal 0. So that means x minus 3 is a factor.